Today we're working on 842, 1 through 23 all. Odd, sorry. 8 to 23 odd. All right. The order of this matrix is a 3 by 2. Now, with matrices, there are two different multiplications. One is called scalar multiplication, and the other is called matrix multiplication. A scalar, which is something you've done lots and lots, scales a particular problem. So we have dealt with quadratics, and we have scaled the quadratic, which means you multiply the entire thing by 2. Does that change the graph? What does it do to the graph? It's twice as tall. Okay. What does it not change? The roots no longer change. The y-intercept changes, but the x-intercepts do not change. What this means is we have scaled the graph. We have changed its scale. So that is called scalar multiplication. We can scale matrices. So if I put a 2 out front, what do you think that's going to do? It's going to double everything on the inside. Is all of my original information still there? Yes, it's just twice as big as it used to be. So the information is intact, it has just been scaled. Okay? The other thing you can do is add matrices together. So if I had how do you suppose you add matrices together? So the row 1, column 1 point, so the 4 and the 8 add together. So this adds to that, which is 12, and it creates a new matrix. This added to that is going to be -7. This added to that, 3, -2. So if we add matrices together, something has to happen. They have to have exactly the same order. A 3 by 3 can only be added to a 3 by 3. You cannot add a 3 by 3 and a 2 by 3, even though they have the same amount of numbers. So if I had 1, 2, 4, 8, 6, 0, and I added it to this, you cannot add those together. They have a different order. They have the same number of points, but you cannot add them together. Now, we're going to talk about matrix multiplication later. If you multiply matrices, they do not have to be the same size, which is really weird. But matrix multiplication is quite strange. So, yes, you can. So if I had this matrix and another one like this, actually let's do 8, -1, and I called this A, and I called this B, I could do A plus B. Just add them up. I could also do 2A minus 3B. What does that mean? Scale A by 2, and scale B by -3, and then subtract. Or, this is the same thing. We could do anyway, I could scale this by -3, multiply in -3, and then add. Or I could scale by 3 and then subtract. So that middle section, take a look at page 842. Look at number 10. It says 10, on number 10, those two matrices are the same. What's the value of x and y? Well, x has to be 10 and y has to be 12. That was tough. Look at number 12. Now I have x is equal to 2 plus y, and y is equal to 5. This is a system of equations. X equals 2 plus y, and y equals 5. So the coordinate would be, plug this in, 2 plus 5 is 7, comma 5. Okay, look at number 14. So a squared equals 9, and 2b plus 1 equals 9, and 2a plus 1 equals negative 5, and b squared equals 16. So a would be equal to plus or minus 3. So if I square root these, plus or minus 3. And b is equal to plus or minus 4. What about these? Well, does 3 or negative 3 work? So if I plug positive 4 in there, it works. And if I plug in negative 3, so what are the answers? It's plus or minus 3 and plus or minus 4. So if I just solved this, I subtract 1, I get 8, divide by 4, I get b, or divide by 2, I get b equals 4. That's one of the answers, as long as it works everywhere. If I solve this, I get a equals negative 3. But negative 4 also works here. It doesn't contradict this. That statement's still true. It just provides a second answer that could be true. So what do we do? Is it one or both? Do they both work everywhere? No. So it's just the one. So it's negative, or it's positive 4 and negative 3. Okay? Good luck.